All right, these last two problems I didn't get to in the lecture in class, so I'm going to work the solutions right now. This one here, solve this system. So, you know, they're both solved for y, so if you plug this one back into here, you get 1/2 x minus 1 equals 3 cosine pi force x. Now the problem with this is you have an x inside a cosine and an x outside the cosine. Like, you're not going to be able to solve this by hand. Let's say we divide by 3. I get the little move tool. Sorry, whatever. Equals cosine of pi force x. So if I want to get this x out of the cosine, I need to take the inverse cosine. But if I do that, then I get an x inside a cosine. So now I got to take the inverse cosine. So now I got to take the cosine. As you can see, when you get it out of the one function, it puts it inside another function. So you can't isolate the x's by hand. So what do we do? This is one that we're going to try to solve graphically. So it's a little bit of work here, but we should be able to graph these functions. So the period of this function is 2 pi over b. That's pi over 4. So the period is 8. So 1, 2, 3, 4, 5. So 8 is there. Then you divide it into 4. 1, 2. So my tick marks are kind of like every 2. I know it's a little hard because I already have a graphed grid, but that's okay. And then the cosine is up. It starts at 3, and it goes down, down, up, up, down, down, up, up. So this function looks like this. Oops, sorry. Something like that. And then this function is just a line through -1 that has a slope of 1/2. So up 1 over 2. Oh, there's the intersection. Up 1 over 2. Up 1 over 2. Up 1 over 2. Oh, there's another intersection. Down 1, back 2. Oh, there's another intersection. So this function that we couldn't solve by hand analytically, we can kind of see graphically that there's 3 solutions. They are -4, comma, -3, 2, comma, 0, and looks like 8, comma, 3. Now, I don't know if you guys see this, but if we were to zoom in on this, this thing is rounded, and this function, and then this line comes up on it like that. We probably need to analyze what happens here, and if there really is just one point of intersection, as in the line is exactly tangent to the function, the cosine curve, or if it hits at 2 spots. So to do that, let's graph that in the calculator. Graph. 0.5x minus 1, there's the linear equation, and then cosine, 3 cosine of pi x divided by 4. So there we go. So I can kind of see, actually it doesn't really look weird, it looks like it's moving around. But I can see that it crosses here. If I go to menu, analyze, intersection. So there's the first one I got. Menu, analyze, intersection. There's the second. There's the third. But if you zoom in, if you do a zoom box here, you're going to see that there actually is another point of intersection. And unfortunately, we can't find that one. The calculator can use numerical methods to solve it, but this graph, zoom standard, this graph actually has 5 intersection points, of which we can only find 3 of the 5. Okay? All right. The last one, what am I doing on time here? 5 minutes. I think I can do this last one. Last one is a little bit of a throwback to the old Algebra 1 days. Distance, rate, and time. Rate times time equals distance. Bernoulli lives on a road 50 miles from Copernicus. So here's where Bernoulli lives, west of Copernicus. So we'll say backwards. So, oh wait, Bernoulli and Copernicus. That's 50 miles. Copernicus leaves her house at 8 a.m. and travels east along the road, traveling at 30 miles an hour. So she's going to take off here going 30 miles an hour. Bernoulli leaves his house at 9 a.m., so an hour later, and he's traveling 40 miles an hour. Traveling east. How far from Copernicus' house are they when they finally catch up? So what's going to happen is, because he's traveling faster, eventually he's going to catch her, and they're going to meet at some point P. So the question says, how far are they from Copernicus' house? So the question is asking for this distance here. Distance between Copernicus' house and their meeting place. All right, I don't know if you guys did this or remember doing this in Algebra 1, but sometimes the table of values helps you organize your information. I like them. We got Bernoulli, we got Copernicus, and we know rate times time equals distance. So let's start filling in the stuff we know. Bernoulli travels 40 miles an hour. Copernicus travels 30. Time. Well, I don't know how long either of them travel. So let's just say Bernoulli travels Copernicus travels t time. Left at 8. Well, Bernoulli, if Copernicus travels t time, then Bernoulli is going to travel 1 hour less because he left 1 hour later. So the distance in terms of t that Copernicus travels is 30t. And for Bernoulli, it's 40 times t minus 1. So here's the distance that Bernoulli travels. And here's the distance that Copernicus travels. So those distances aren't the same. If I wanted to equate those distances, and I could even put these labels up here if I wanted. This is 40 times t minus 1 distance, and this one is 30t distance. If I wanted to come up with an equation to relate these things, I would say Bernoulli's distance, 40 times t minus 1, is equal to Copernicus's distance plus 50. So 50 plus 30t. And there we go. Solve this equation for t. Subtract 30t gives you 10t, add 40t gives you 90. So t is equal to 9. T is my time, so that means Copernicus traveled 9 hours and Bernoulli traveled 8 hours. That's not what the question asked. The question wanted me to find this distance here. Well, that is just my 30t. So my final answer is the 30 times t, which is 9, for a final answer of 270 miles. Yep. Have a good day.